Hey grade 10s, welcome back. So today we are continuing in our optics discussions. Today we're going to look at color theories. So we're going to look at both the additive and subtractive color theories and how we can see color. So just a reminder that the electromagnetic spectrum includes visible light, and remember that it's white light that is separated into the different colors of the rainbow. So we are going to look at the additive color theory first. And the additive color theory talks about how light combines together. And so it says that white light is composed of those different wavelengths of light, and that all of those colors together produce white light. But another part of this theory is that it's possible to get white light by combining only 3 colors. And so those 3 colors that can produce white light are the primary colors. And the primary colors of light are different from the primary colors that you learned about in kindergarten. Those are the primary colors for pigment. The primary colors of light are red, blue, and green. And when you combine red, blue, and green light, you get white light. So if you mix equal amounts of the 3 primary colors of light, you get white light. But if you take only 2 of those primary colors of light, you will make a secondary color. So the secondary colors are magenta, yellow, and cyan. If you mix red light and blue light, you will see magenta light. If you mix green light and red light, you'll make yellow. And if you mix blue and green, you will make cyan. So that's pretty much what you need to know about the additive color theory. And we'll do some investigating with that in class. And so now we're going to move on to the subtractive color theory of light. So the subtractive color theory helps us to explain how we see objects, the colors that they are. So when a light wave strikes an object, it's usually a white light wave, but not always. Some of those wavelengths of light are going to reflect off of the object, and that means that they're going to bounce off. Other wavelengths of light are actually going to be absorbed by the object, so they're going to be taken in. The color that you see when you look at an object depends on what wavelengths are reflected to your eye. For you to be able to see them, the light has to hit your eye. So like I said, the subtractive color theory says that colored objects will selectively absorb and selectively reflect different colors or wavelengths of light. So the colors that are absorbed by the object are actually subtracted from the reflected light that is seen by the eye. So it's subtracted from the white light. It's subtracted from what is going to reach your eye. And so again, if a color is absorbed, it's not going to make it to your eye. You only see the reflected colors that will make it to your eye. The reason that we see black objects as black is because they've absorbed all the colors. So none of the colors that make up white light, none of the colors of the rainbow are actually going to make it to your eye. Whereas a white object appears white to you because all of the colors of the rainbow, all of the colors that make up white light have actually been reflected into your eye. So just to kind of go through an example, a red object appears red because it has particles of pigment that are absorbing those other 2 primary colors of light, blue and green. So those blue and green colors have been subtracted from the light. The only light that is reflected is the red light, so that's what you see. Seeing an object as yellow, on the other hand, means that blue light has been absorbed, but green and red light have been reflected. And when green and red combine, we see yellow. So just to make things interesting, the subtractive color theory of light actually has primary colors that are opposite to those of the additive theory. So the primary colors for the subtractive color theory are cyan, magenta, and yellow, whereas the secondary colors for the subtractive theory are red, green, and blue. So there are many, many applications for these color theories of light, and one application for the subtractive color theory is in the manufacture of paint and pigments for painting surfaces and objects. So the primary subtractive colors will be combined or mixed in different amounts to make a whole range of colors that can reflect from a surface. If you have an inkjet printer and it's a color printer, you might have 3 different color cartridges, and you'll know that there's cyan, yellow, and magenta, and those will combine to produce color on the page that you've printed out from your computer. So filters also work by using the subtractive theory, and the reason is that these filters of light they contain pigments, so they're a different color. So for example, this blue filter is going to allow some of the light to be transmitted through, but the pigments that are in the filter are going to absorb some of those light colors. So this blue filter is going to absorb the red and the green light, and it's going to allow the blue light to transmit through. And so that's why we'll see blue light. So what light colors do you think a cyan filter would absorb, and what colors would it transmit? So it would appear to be cyan in color, and so cyan, the light would appear to be cyan. So for that to happen, red would have to be absorbed, and blue and green would have to be allowed to transmit through, as those would combine to produce cyan. So thanks for listening to the different color theories, and I will see you next time.